Hello, everyone. So, welcome. First and foremost, thank you all for taking the time to joining us, and welcome to the LinkedIn Live session. I am Sharath Thirumalai, Senior Analyst within Everest Group in the service line of Advanced Sci-Tech. And I'm also joined by my mentor, Cecilia Esther Van Kouwenberger. She's the Research Director. So we work with the Environment, Sustainability, Chemicals, and the Advanced Material Department within the service line of Advanced Sci-Tech. And welcome, Cecilia, first and foremost. And before we introduce our guests to the audience, I would like to talk about the importance of this LinkedIn Live, and because this is the most essential topic of the modern day, industrial decarbonization. The massive challenge is to achieve deep decarbonization in the long term, but at the same time, we need to make sure that it's environmentally and economically viable, and it's kind of genuinely transformational as far as sustainability is concerned. So keeping all this in mind, the challenge still needs to be answered to achieve the long-term goals. So in this regard, apart from electrification, which is actually a low-hanging fruit within the industrial decarbonization, hydrogen, an effective energy carrier, has the potential to decarbonize hard-to-abate sectors. However, current routes in producing or generating hydrogen, or low-carbon hydrogen for that matter, to be precise, and other clean industrial feedstock from hydrogen has pushed us to a new limit, because scaling, the time taken to produce it, or even the cost for that matter, there are a lot of challenges and gaps there. So particularly, this is why we have this LinkedIn Live session. We want to introduce a topic which is slowly but steadily making transformational changes or radical changes within the realm of industrial decarbonization, and that is the technology of methane pyrolysis, or in the shades of hydrogen, turquoise hydrogen. It has been like a stopgap solution, but it could be a reliable solution in the long term. To define methane splitting, it's basically thermochemically breaking down methane into hydrogen and solid carbon under proprietary catalyst without producing CO2 emissions. So this process, while also creating low carbon hydrogen, it also creates solid carbon, which can be a useful byproduct in kind of value added high-end applications, and it can give us a lot of revenue and profitability for that matter. So this methane pyrolysis will offer a lot of advantages like low carbon energy savings, scalability, and potential to turn a byproduct into a value added resource. So this would be actually a blessing for countries within Middle East and Asia Pacific, where they are reliant especially on natural gas or seeking decarbonized hydrogen. So today's session will explore the technology know-how, the economics, the industrial dynamics, and policy frameworks at play as far as methane pyrolysis is concerned, and how methane pyrolysis has come from a laboratory scale to a pilot and to a commercially proven scale. So before we deep dive into methane pyrolysis, I would like to take this honor of introducing our guest speaker today. He is the founder and CEO of Hycamite TCD Technologies, which is basically a Finnish clean tech company which is dedicated to industrial decarbonization. If I have to give a short speech about his company or about him, he's been a seasoned clean tech entrepreneur, and he has spent around 20 years of research in Finland as far as this thermocatalytic decomposition of methane is concerned. So, and their company has also commissioned Europe's largest methane splitting plant for low carbon hydrogen production. So within this, his technology, if I have to say that it's a game changer, it's actually an understatement, because their company's technology reduces energy consumption by 87% as compared to green hydrogen, and reduces carbon footprint by 90% as compared to gray hydrogen. So we are privileged to have Mr. Mati to join us. And before I give him the floor, I would like to know more about his journey, what problems did he solve, and the importance of methane pyrolysis in the hydrogen economy. So the floor is yours, Mr. Mati. So yes, please enlighten us.
Well, thank you, Sharath. A couple of points to perhaps correct the first, so that I'm one of the founders, yes, but I'm not the CEO actually. I'm the chairman of the company.
Sorry for that. Yeah.
No worries. I mean, this is a live event, and this kind of things happen in the live event, and that's the salt of it. So yeah, I've been a clean tech entrepreneur for more than 20 years, and Hycamite is my third company, and been established, as you said, under the development that the people were doing in the University of Oulu in Finland, and we just found out the idea, or I learned about the idea in a seminar in Germany, and then we decided that okay, let's give it a shot, and here we are. But happy to be here. Thank you for the invitation.
Yeah. So I mean, could you talk about the importance of methane pyrolysis within the hydrogen economy to begin with?
Yes. So as we all know, the situation is so that the hydrogen hype was built very much on the green hydrogen, and when you go into the hydrogen summits nowadays, it's quite often discussed that okay, the hydrogen is dead, or the hydrogen is having a hangover or something like that one at the moment. But that's not really the case. It's only the green hydrogen that is having the issues at the moment. So that when the whole hydrogen hype started, there were people that were thinking that like us that first of all, you cannot make that kind of ecosystem where you all of a sudden pay like 5 times more for the media to be just renewable and low carbon. So we need to start from somewhere else. And don't take me wrong, I'm not against the green hydrogen. I've never ever been, and I will never ever be against it. But I just think that the time is not right for it yet. So we need to go for the low carbon hydrogen now, where we can actually turn the ecosystems into using more hydrogen, being more decarbonized, if you will, and so that we are having these ecosystems, and then later on we can start building up the whole industry, more and more renewable and so forth. It's all about avoiding the CO2 emissions, and it's all about that we need to offer the hydrogen with the prices that the customers are accepting and willing to pay for. So that is where all these low cost or low carbon hydrogen appliances or applications come from, and we include it. Then perhaps if I continue there, so that for the benefit of the audience, so that why the low carbon hydrogen then can be affordable, it is simply that in case, for example, with the methane splitting, we are splitting methane, i.e. the major component of natural gas or biogas, into low carbon hydrogen and solid carbon. The carbon we usually discuss when we're talking about the carbon capturing. People are saying that that's carbon, i.e. it's gaseous, but that's actually normally when talking about carbon capturing, we are talking about the CO2, carbon dioxide capturing. In our case, we are talking about capturing carbon in a solid form, and we can valorize that value so that we can actually make other products out of it, and then with those products and with the revenue stream coming from, then we can then supplement or make the hydrogen as well more affordable.
Thank you for that context, Matti. So continue with this transition to more the technical heart of the process. So we understand that Hycamite's thermocatalytic approach has been described very efficient and controlled methods for precisely converting this methane into hydrogen and solid carbon, as you properly mentioned. So for our audience and also for us, so would be valuable to understand how this actually works in practice, taken from your last words. So if you could walk us through the core mechanics of the process, the time of methane, base feedstocks, your system is currently designed to handle the features of the hydrogen and carbon streams that your technology produce, and it could be really great to fully understand the process.
No worries, Ceci, I will. So when you have methane, whether that's coming from biogas or from natural gas sources, you usually have some sulfur in it. People actually even add some mercaptans and so forth just to to give the smell. So we need to start by removing that, and there's an industry standard way for using zinc bed reactors or filters to use take out the sulfur. I mean, they are very small contents, but anyway. So we do that first, and then we heat the methane, and we forward that heated methane into the reactor where our catalyst is present. So we have developed 5 different catalyst families, and they all produce a little bit different kind of carbon products. So hydrogen is of course always the same, but with the help of the catalyst, we can make either carbon nanofibers or, more interestingly, graphitic carbon. And this graphitic carbon is actually so highly graphitic that it has been tested. You can use it as such in batteries. Okay, it's really, I mean, not like a final graphite, but it is so graphitic that it actually already as such works. So that tells to the graphite people that, okay, well, this is then something that is actually quite easily possible to graphitize later. But anyway, coming back to the process. So with the help of the catalysts, we then, break the methane molecule. Then what we need to do is that we need to filter the gas and the solids from each others. And the solids are either the carbon and perhaps some remnants of the catalyst. They continue to the backing and so forth. And then we can start the carbon processing for various products that what we have. But then the gas is so that gas is not purely hydrogen yet. It is a mixture of hydrogen and some part of the methane, because not all the methane reacts in the first go. And after that one, what we have is that we have a membrane system, so that we have a membrane that actually can separate the hydrogen from the natural gas, and then the natural gas or the methane, that part that didn't react on the first go, will be turned back to the reactor, and the hydrogen goes to the customer. So it is actually a very, very, very simple process. For process industry people, this is like, what's the magic in there? And the magic is in the catalyst. So that is the key for everything here. There are a lot of other companies that need to use very high temperatures and so forth, but with a catalyst we can actually use very modest temperatures, so that starting from 600 and upwards, so that we can make this. And that's it. As simple as that.
Thank you. Yes, I think one of the things we observe or we heard, like a pain point for many approaches, is precisely the struggle with catalyst degradation to very high temperatures or operational instability. So thanks for that clarification. So is there own innovation in the catalyst also that allow us to operate with these lower temperatures, or is it the innovation in the process that could work at lower temperatures and then use a milder catalyst?
Yeah, I think that I need to make a disclaimer here first, so that I'm not a chemist. So if there's somebody listening and saying that, okay, well, this is not exactly this way or that way, then excused. But our team has been developing the catalysts, from the very beginning, and I said, so that the know-how base is actually coming from this R&D done, or research done in the local university. But the situation is so that the development of the catalyst is difficult. I have seen a lot of stuff, and we have a lot of equipment and people working in the laboratory for developing those. Very, very skilled people. I'm really happy for the team. I mean, that's what we have. But it is really so that you need to have like a certain know-how there on this catalyst stuff. And when we are developing that one, we are also thinking about how to protect the IP that what we have there. So you asked about the patents and so forth, and we were actually quite recently awarded the first patent in our applications. We have more than a dozen, almost 20, something like that one at the moment, that we have applied for. and there's more coming. So that we are really developing this technology and trying to see that where it can be protected and so forth. The problem with the catalyst patenting is so that if you would make the patent application of the recipe as such, that how you do it, it's like the chef showing that okay, this is how I do the good food, but I think that because of that one, so that you don't want to show the everything there, we are sort of patenting the surroundings, so that how we are using it, what kind of features we have there, and so forth. But that's how it is going.
Okay. So with the catalyst as a context in this place, my next question is, how does you significantly lower the energy consumption by 87% as compared to green hydrogen? And it also claims that it is 90% lower carbon footprint as compared to conventional steam methane reforming. So
Yes.
what is do we have a perfect assumption or a precise condition under which this happens, or could you explain the process there?
Yeah. So first of all, if you think about the energy use, you need to remember that we are starting from a different material than the green hydrogen is starting. So green hydrogen is about splitting water. That's what it is. So that you split the end product, what is being produced when the hydrogen is being burned. In our case, we have like a feedstock that already contains the hydrogen, and the carbon hydrogen bond is not that strong, i.e. you need less energy to break it than you need for the hydrogen and oxygen bond to be broken. So that actually describes a lot about this one. Then the catalytic reaction actually helps lowering the temperatures. This is what the catalysts typically are doing, so that they're making the reaction going easier, and therefore the whole energy use is different. But I think that what's even more there is that when we are heating up the reactor, and in our process the heat is actually the form of energy that we use, then that means that we can even lower the cost of the methane splitting even further, because we don't need power, we need heat and power. So majority of our energy need is heat, and the heat is something that you can even do with a hydrogen. So you can make this actually so energy efficient that you can put it on a ship. And because of that one, we have shareholders now, and we have technical partners that actually wanted us to develop this whole technology to be put on a ship, and we got the approval in principle from DNV for that one just recently. So that is the energy efficiency stuff. Then the other question was about the CO2 emissions.
Yeah. Yes.
So the CO2 emissions, and this is actually my favorite part, because the thing is that whatever we do, I mean, even this discussion that we have a CO2 footprint, the carbon footprint, that's what we are doing. And in order to decarbonize the world, we should think, and foremost, just calculate that what is the whole carbon footprint and how we can deduct that one, because that is what is causing the climate change. So that it is not something else, it's a CO2 emissions. So get rid of those. In the steam methane reforming, what you are doing is that you have the methane, but you use that as a fuel. And then you are making the hydrogen by, as the name says, reforming the steam with the methane, so that you are actually having this carbon there then being burned, and therefore for every kilo of for hydrogen that you produce 10 and even more kilos of CO2 to the air. In our case, there's no oxygen in the reactor, so we can't make CO2. It's a solid carbon, and therefore our carbon footprint is very, very, very small. It is actually so small that in all the cases so far that we have calculated with our industrial customers, when they have compared with a fossil fuel, our hydrogen towards renewable hydrogen, i.e. green hydrogen, that carbon footprint of the green hydrogen has been more than the one that we have. And this is actually the beauty of the low carbon hydrogen production.
Awesome. Yeah.
And there's a question. So is it possible to have the heat source from renewable electricity? So because you spoke about heat having, heat being the main source for the methane splitting. So there's a question.
Yes, thank you, Jafar, for the question, and the answer is yes, of course. So this is what we want to do. We actually want to do as much renewable as possible. For example, the pilot plant that we have now been operating for more than 4 years, we are using biogas there, biomethane. I mean, and that. And in Finland, when we have the first industrial scale plant there, we are buying the local power from the grid, and in Finland it is actually mostly renewable electricity. So yes, that is possible.
Excellent. Thank you for answering these comments, and also, if anyone in the audience have more questions for us, we are more than happy to help with this question. So now that you have a clearer picture of both the technical base of your technology and hydrogen in general, and the emissions profile that you mentioned, that is very interesting to also compare with even with the green hydrogen. So I would like to move a bit of the economic dimension. So
yes,
we understand that cost remains the deciding factor still for widespread adoption of hydrogen in industrial settings. So from Hycamite's perspective, from your perspective, so what levelized cost of hydrogen range do we aim to reach as your technology move towards commercial scale? So it would be helpful if you could describe the key drivers behind the cost trajectory, including also technical things like catalyst longevity or milder conditions or modular plant efficiency requirements.
So all in all, we are the cheapest low carbon hydrogen producer in the world in that sense. So when you're having a look on it, so that how you can and in what kind of volumes you can put that to the customers. So you have green hydrogen that is much more expensive. You have the blue hydrogen, and then you have the gray hydrogen, i.e. the SMR hydrogen. And we are at the moment just a little bit more expensive than the SMR hydrogen, but that is without the subsidies. So if you have the subsidies, then we are even less than the gray hydrogen. We do actually have customers that are already now saying that because they need to pay emission, payments, emission taxes for the hydrogen production, that is already enough offsetting them so that they want to go for our solution. So it is, we are really very much there. And actually, this is like the whole thing, what we have in the company. So that when we founded the company, we are 3 founders. We were talking a lot about in the early days about this one, that okay, is this company actually a hydrogen company or a carbon company? Because when you are splitting the methane, you have both, and this is even in the name. I mean, you have it. So Hycamite, hydrogen, carbon, and so forth. But the situation is so that you need to create a business that stands with its own feet, so that you cannot have the business so that it is based on subsidies or something like that one. And there the value of the carbon actually stood out very, very early days, so that okay, we have to have really, really nice carbon products that can actually support the whole hydrogen stuff as well. So all the other or most of the other methane splitting companies are making carbon black. We don't. As I mentioned, it's carbon nanofibers and it's graphite carbon. And we really think that, especially now with the geopolitical situation being what it is, the graphite that we can do in big volumes and really like locally from the local sources, that is the key for the success. So that it is actually the carbon business that is supporting the hydrogen business. So
yeah. So your question is leading, your answer is leading me to the next question.
Yeah,
From the
I have
hydrogen
a
angle.
comment before. Sorry, Sharon. No, because well, it's interesting. I received a comment during the past weeks related to this event, and one of the comments was, "Well, we could do something like that, but actually, we do not know what to do with this." With the carbon, considering literally like a byproduct. So it's very
Yeah.
interesting the way that you can these like well also the core business of your enterprise. So Sharad, I'm sorry,
Yeah,
you can
no
go
problem.
ahead with the next
So
question.
leaving the hydrogen, the main product, I would like to delve into the byproduct, which is the solid carbon. So I just wanted to know, you have already spoken about it, but I wanted to stress the fact that there is also a question here. Do we have to have a purification step to separate the solid, or to further purify the solid carbon, or we just use it as well? Or what are the future potential applications for the solid carbon? So if you could shed more light
Yes,
in.
of course.
Yeah.
And this is a really good question, by the way, so that I'm really thankful for it. So we have at the moment, I believe, something like 17 different applications that what we have developed in the company. And we are working on. And some of the applications, like, for example, the steel industry, when they are needing this for alloying purposes or for slag formation and so forth, it is actually usable as such. Perhaps you need a little bit like a small step of agglomeration or something like that one, but not really more. I mean, it is very, very, very simple way to utilize it. The same goes actually with some other applications like concrete and tire industry that what we have tested. But then when we go to the electroconductive polymers and for the graphite especially, then of course you need to have more and more understanding of the carbon product. The audience might not know where I'm from. I mean, where the Hycamite is based, so Kokkola, Finland. But an example that why we are there and what is the strength that what we have in that city is that now recently we were given by the European Commission this strategic project status, so that Europe decided that okay, there's 47 projects that are really critical for the future of the Europe. Okay, Hycamite is one of them, and we are very, very, very proud of this status. It was not an easy task to make, and there were a lot of big companies that failed. But yes, we are there. But guess what? In Kokkola, that is a small town, there's 3 other projects that are there as well. I mean, well, 3 together, but then the 4th one was actually the technology was developed there. So 4 out of 47 projects are coming from that small city in western part of Finland. And that just tells you the know-how that what we have there. So the carbon is what I understand, and please remember that I'm not a chemist, but what I've learned so far is that it is really, really, really precious material in that sense that you can make it for so many different allotropes, so that you can have everything from barbecue coal to diamonds and everything in between. And to make that carbon so that it's really usable, that needs some people that really understand the situation and how to develop it.
Okay, so my leading question here is, how is like agreements related to solid carbon byproduct purchase will sort of de-risk a large scale low carbon hydrogen pure hydrogen projects? So could you tell us more about the importance of licensing or selling the byproduct solid carbon, so that financially there is a de-risk here in terms of scaling up the hydrogen production? So if you could talk about that.
Yes, everybody in the hydrogen business understands that what is the importance of the offtake agreements, so that if you're making hydrogen or you're making hydrogen related products, that is like the key that how your business will start moving. Luckily for us, we have a little bit everything in the carbon product, so that we have customers that are willing to make really long offtake agreements. So like for example, in graphite business, it's a standard. So that okay, we'll start with like 10 years or something like that one. So they are really when they establish those battery companies or battery factories, they really want to secure the graphite, deliveries and so. Then we have also quite a lot of carbon products that can be sold with a almost like a drop-in product base, so that we can sell this to steel industry, and they use other sources, and then they can, when needed, they can take ours. I mean, when needed from our side, so that we say that okay, now we have carbon available for you, and they are happy to take it. Why they are happy to take it? Remember that I told that we are removing the sulfur. So our carbon doesn't contain the sulfur, so that they can make better quality steels out of that one. So this is all like a mixture that what you have there, but you are hitting the nail in the head in that sense, that it is important and it has to be balanced.
Yeah. Okay. And there's a question here. So how does the process proceed? Does the process proceed via methane dehydroaromatization? So that is a question.
First of all, I do not know the word dehydroaromatization. I'm not a chemist, but if I, in layman's terms, try to explain it, so that you have the methane molecule and you have heat, and when that molecule hits the catalyst surface, the reaction happens so that the hydrogen separates from the carbon and so forth. But what I think is actually the like the chemical chain is that the whole splitting takes place, so that you have like a longer hydrocarbon chains, and then eventually only carbon is left. But I don't recognize that word. Sorry about that. We can come back to that one in the comments later on.
Sure.
Of course. So, and we understand well one of the risk or one of the ways in that the risk operation is also well to take this focus on on more core products beyond the hydrogen, right? So, but also your company you emphasize the modular plants that can be co-located with methane consuming industries, a way that also the risk the process and reduce complexity, lowers entry barriers. So could you describe the smallest module that is technically and economically viable, or outline how it works in the reality with a typical customer?
I think that the smallest site is highly dependent on the markets, of course. So that what is the cost of the natural gas or the biogas, and what is the use case, and so forth. At the moment, the site that would be having Kokkola is having a nameplate capacity of 2,000 tons of hydrogen per year, so 5.5 tons roughly per day. And I think that that's on a smaller side. So our customers are seeing that we should make 10 KT, 30 KT, and so forth plants in the future, and this is then something that the industry is also willing to accept more. The beauty in methane splitting technologies like ours is that we don't need the hydrogen infrastructure. So the natural gas infrastructure is already there, and as Ceci quite rightly said, we can go to the methane, to the customer that is using methane. So we can go there and decarbonize them as such, and then start taking the benefit of these highly valuable carbon products. So we can really scale this up actually quite quickly.
Mm-hmm.
Okay. So my next question is on the regulatory level. So I just wanted to know, you spoke about how Europe considers Hycamite as one of the 47 projects. So could you talk about how does it fit within the frameworks like the Green Deal in the EU, or the infra, the IRA, or the other American framework schemes. So, and what will be the biggest regulatory challenges as far as the short term is concerned within the next 2 to 3 years?
So, first of all, we are a new technology, and the problem with all the new technologies is that they are not well usually considered in the regulation.
Oh.
And this is something. I was just recently in a seminar in Canada, where we were talking about the regulation, that how actually worldwide it is happening. And the problem is that we have this regulation coming from and supporting, say power generation, distribution, oil and gas. I mean, all these different parts of the energy scheme, if you will. And every single portion has their or segment has their own regulation. Now with the hydrogen and with the batteries, we are making cross connections. So we are actually working in separate parts of the regulation, and this old regulation doesn't work well with anything new. So this is a concept for or a problem for not only for the Hycamite, but for other technologies, other new technologies as well. In our case, USA, Canada, UK are actually quite well advanced. Also Norway, where they have based their regulation on the CO2 footprint. The Green Deal in Europe, that was on the former Parliament time, did not support turquoise hydrogen, or actually any other hydrogen than green and blue at all, and that was a shame. So that it's really, that's not the way that how the regulation should be done. Now we have the Low Carbon Hydrogen Delegated Act in place in Europe, and that supports us already. Not with the full swing, I would say, but it's definitely getting there, and there's more and more coming. Globally, there's a new ISO standard coming, ISO 19870-1, and that is based on the older or the previous ISO standards. And actually, that one, what we understand, is supporting actually quite well our kind of technologies, because it's more technology neutral approach. And I hope that in the future we are there everywhere, and not just with the methane splitting, but with other technologies as well, so that we will start seeing this kind of technology neutral approach.
Mm-hmm. Yeah. And what about investments? So you recently welcomed new investors from heavy industry and logistics, with, of course, signals readiness to scale. We understand these partners can accelerate different dimensions of growth: the market access, the engineering capability, supply chain integration, even financing strength. So, but could you describe what these investors accelerates most directly for Hycamite, and how their involvement strengthens your next phase for commercialization?
I would like to give like a school book answer here. so not a company specific in that sense, but
Okay.
typically for this kind of companies where you are developing something new like this way, you of course need to have the so to say seed investors and all the early stage investors in place. But then for us, when we actually were able to get our first industrial investors joining the company, they have been of a great help. So they have been helping us in order to understand the industry and understand that where we are, what we should do, and how the regulation with their end goes, and all this kind of stuff. So there's a lot of support coming from that. But then the next phase is that you need to also then start going for the financial institutions. I mean, investors that are having broader shoulders, in that sense that we can start talking about the project investments and all this kind of stuff, and then you need to show the commercial how to say viability there, and all this kind of stuff. and this is important to understand that every startup, every growth company, we have our own steps, like a life parts or milestones that you need to go from one to another one, and Hycamite is no exception in this case. So that this is how the business works, and this is what we should do as well. So that I'm willing to see more and more financial institutions coming to support us in our growth. They also bring new kind of understanding of the markets on the project financing side and everything. The world is a little bit different there than just for the technology development, but this is important.
Yeah, thank you.
Okay, so my question is in terms of commercializing it in a large scale in the future. So you mentioned that you only use abundantly available proprietary catalysts. So how is your strategy in terms of using abundantly available catalysts to scale up for large scale production of low carbon hydrogen and solid carbon? So if you could tell us about the catalyst procurement and scaling up of large scale projects in the future.
So we actually produce our own catalysts. Okay. So they are multi-metal and other so to say catalyst materials where the core know-how that how they are made is our secret sauce, if you will. And we want to keep it that way. And from the very, very early days, we have started to see that, okay, how we can make them, how they can be, what kind of so to say, ranges you have, that what is the consumption of the catalyst and how often they need to be regenerated and so forth. So this whole cost following there is an important part of the business. But it is actually a good question. So it just shows that there are so many aspects in this kind of business that you need to take into account when you start thinking about the serious growth. And this is, of course, one of them as well. But we believe that we have the answers for those.
Okay. So my final question to you, Mr. Mati, I don't want to take much of your time, is to do some stargazing and predict the future of the hydrogen economy in terms of 2030 and 2050. I'll give you a context. So the context is that I would like to take the air transport as a decarbonization example. The International Air Transport Association has said that by 2050 they would like to use 65% of their global fuel supplies in terms of sustainable aviation fuels. Now, if you see the current situation of sustainable aviation fuel, by 2025 it is just less than 1% of the total production required for achieving 100% sustainability within the air transport decarbonization angle. But by 2030 they would like to go from less than 1% to 5%, and then to achieve almost like 50 to 60% by 2050. And Europe goes a step higher and says we would like to achieve 75% of our global fuel supply through sustainable aviation fuel. So within the context of sustainable aviation fuel, there are only two routes. One is the biomass route and one is the green hydrogen route, where they use green hydrogen with carbon dioxide to produce power to liquid or the renewable sustainable air fuel. So with a lot of green hydrogen projects installed or going slowly at the moment, I don't know whether they will be able to meet the targets. So I think this is where a potential opportunity for a low carbon hydrogen through methane pyrolysis can be used. So what do you think about this angle? How will this be a future springboard for making it large for turquoise hydrogen is concerned? So I just wanted your angle here.
Can I comment the question first before answering it? So that this is so wide question that we could have a totally different series about it. But
just giving you a context here,
yeah. So I think that from my point of view, it again comes to two things. So first of all, you need to have the low carbon or renewable hydrogen. That is one piece that you need to have. The other piece is the CO2. So that you need to have those that you combine.
Yes.
And if you have a look on the regulation at the moment, so that if you are using or making like SAF fuels, you need to have renewable CO2. And
Correct.
that is, I mean, I'm not talking about purely European ways and so forth. So the problem is that we don't have that much renewable CO2. So that is a limiting factor, and therefore we need to start thinking about actually rotating the CO2 from other sources, so that if there's, say, a cement factory that produces a lot of CO2, would it still be better, instead of just releasing that immediately to the air, capture that one and then make another fuel of it, and only then release it up to the air and so forth, so that we can get this like a prolonged emission paths and so forth, and seeing the circulation a little bit different way. But that is really difficult, I have to say. We are seeing it that way, that Hycamite is providing low carbon or ultra low carbon hydrogen, and we would love to see a lot of projects that are using that, whether, for example, for e-methanol or other fuels like that one, or ammonia and so forth, and we would like to to focus on our part of that one. Also, I mean, I was just in a hydrogen summit where, for example, Airbus was showing their development on the pure hydrogen planes and so forth, and there might be some quite wild ideas coming in 20 years time or something like that one, but let's see. And on the short haul aviation, of course, the batteries are also starting to play an increasing role. So
okay.
Yeah.
Another angle is the future of the solid carbon, as far as selling the solid carbon to EV batteries for EV production. So if you could also, in terms of graphite use in other defense applications or whatnot, so if you could tell about the future opportunities for solid carbon as well.
Well, graphite is now our crown jewel, if you will. So that is, we have really good results. We know that we are even able to meet and even go beyond the existing graphite producers qualities and so forth for the synthetic graphite. So we see a lot of potential there. But of course, we are also thinking beyond, because when you start making this kind of new carbon products, and you realize that actually we are doing this graphitic carbon that is highly, very high quality, and then you realize that if you twist it a little bit more, then you can make perhaps some graphenes, and you can make some new materials and so forth. So we see a lot of potential there, and we have actually already even published some articles about those new developments that what we are getting. So there's a lot of potential, I see.
Okay, so yeah, it almost brings me to the end of the session. So if you could, conclude by giving us the future milestones of Hycamite in terms of the facilities or if you're going to expand into other regions, yeah, if you could finish off with that. And then just a reminder for the audience, there will be a complimentary session. So if you could give in your questions, we would scan the QR code, and we could give us a subject matter expertise for your questions in private. Yeah. So yes, Mr. Matip, so please conclude it by giving the future commercialization milestones which we should be watching out for as far as Hycamite is concerned.
Yeah, well, we did receive, as I mentioned, this strategic project status from European Union, and the pathway that what we have there is that we want to now first make a graphite, like a first phase production facility in Kokkola, and that is the financing discussions and everything related to that one are ongoing at the moment. So we really see forward in that sense that we can actually demonstrate on one side everything from methane to hydrogen that we can demonstrate now as well, but also the solid carbon, so that we can show that what kind of different high quality graphitic or graphite products we can make from there, and also demonstrate that how low, for example, the carbon footprint of that graphite will be, because that is also a key thing. So that we are thinking that we are like perhaps 1/8 of the existing carbon footprint also there. After that one, I think that what we should have also is an other first commercial site somewhere, and with this one, then we should be in a position that we are able to provide the commercial viability of the technology and also all the technical viabilities, and then we can start really scaling up the whole business. So that is how we see it.
Yeah. So thanks there. So that almost brings the end to this lovely session. I have no words to thank you, Mr. Mati. It was truly amazing. It was like we went into a new world of low carbon hydrogen, to be honest. And
Yeah,
if
absolutely.
you have anything else, yes, CC, if you have anything else.
No, just only thank you, Mati. Really, I mean, there are new approaches, and I think, well, the future of decarbonization could be a combination of many solutions, but this one for sure fill the gap of many of the other technologies, especially when you really try to deploy and make these ideas into a reality. So really happy to have a conversation with the leader ones, and well, happy to know that people, well, through a conference in Germany now is is here with this idea, make a reality. So,
Yeah.
Yeah, our pleasure.
Okay, no, pleasure was mine. This was a great discussion. So thank you for this. Thank you for the invitation.
Thank you.
Thank you all.
Thank you.